Hi once again guys. In this video we're actually going to talk about quite a number of things, so let me just begin. First we're going to talk about the importance of declaring a proper data type of pointers. I think I've already mentioned a little bit about this in a previous video, but now we're going to talk properly about it. We say that a pointer to an integer points to an integer itself, but in reality the pointer only holds the address of 1 byte of memory. That is, an integer actually occupies 2 bytes of memory, but a pointer only holds a value of 1 byte of memory. So how does a pointer point to the integer? Well, I'll explain soon, but what I wanted to make clear was that even though an integer has 2 bytes of memory, the pointer to an integer only holds the value of the first byte of the integer. Similarly, if we have a float, it'll occupy 4 bytes of memory, but then the pointer to the float actually only holds the value of the first byte of memory. That is, if it occupies 131, 132, 133, and 134, the pointer only holds the value of 134. So how is it that when we do this, consider the following code, int star b. So basically we're declaring a pointer b, then we're declaring an integer a, and it's equal to 5. Now we're using the ampersand operator. So let me remind you what the ampersand operator does. If you have a normal data type, what the ampersand operator does is find the memory address in which that data is stored and return it. So basically b is becoming the memory address of A, and that's what B is supposed to hold because it's a pointer. And then we say cout star B, and let me remind you what the star operator is supposed to do. If we have a pointer B, star B is supposed to go to find the value that the pointer is holding, go to that location in memory, and find the value that's in that location in memory. So the pointers integer a, let's say, is in 101 and 102. B refers to B is 101. So what star B does is go to 101 and look into it. But we still get the output 5 as if it's looking at both these elements, both of these bytes. This is because it actually is looking at both of these bytes. It knows that even though B is only pointing to the first one, it needs to look at both because you've declared the type of B to an integer. So it knows that B should point to an integer. So whenever you have the first byte of B and you want to print something or something like that, it'll evaluate both the first byte and the second byte and print it. So I hope that made sense. So let me explain once again. Let's say A is in both these values. The pointer and B is given. A B is supposed to be a pointer to A. B holds the value 101, and yet, but when we say cout star B, it accounts for the fact that the part of the integer will also be stored in 102, so it evaluates 101 and 102 and prints it. That's why we still get the proper output 5. Similarly, for a float, if this is a float a and the pointer b to a float points at 131, when we say cout star b, it still prints the whole float because it knows that the float will some parts of the float will also be stored in the other 3 bytes of memory. So when we say star b, it evaluates this along with the next 3 bytes and then prints the value. So I think from this it's pretty clear that it's important to declare the type of a pointer correctly. To make this idea what we just talked about clear, consider the following code. Int star a, basically declaring a pointer to an integer a, and then declaring a float b equal to 3.14, and then we say a is equal to ampersand b. So a will now hold the value of the first byte that B is occupying, and then we say cout star A. So let's say B is stored here. Once you make it, A is equal to ampersand B, so A will hold the value 216 because that's the first byte of B. But we say cout star A. According to the program, a is a pointer to an integer. So when we say cout star a, it'll only evaluate the first byte and the byte after that. So it'll only print what is in 216 and 217. So the statement cout star a will lead to an inaccurate output because the pointer to an int has been used to point to a float. If a was instead a pointer to a float, then it would know that if it's given 216 and it has to do some operation, it has to consider 217, 218 and 219 as well. But this is an int, so it'll only consider 216 and 217, and so you'll get an inaccurate output. Now I'm going to introduce you to pointer arithmetic. At first, I'm just going to tell you what happens when you do arithmetic on pointers, not why it's been defined that way. That'll become clear in the next few minutes. So if we have an int, a pointer that points to an int, so basically that's called PTR. So int star PTR, it points to an int, it's a pointer, and its name is PTR. So PTR initially holds the value 101. If you plus PTR, it'll increase by 2 bytes. It'll increase by the size of the base. So 101 will become 103. Similarly, if we have a pointer to a float PTR, and PTR initially holds the value 101, it'll plus PTR will make it 105. It'll increase by the base of the type, and it'll increase by the size of the base, and the base is float, the size of float is 4, so it becomes from 101 to 105. Let's say we have a pointer to an integer that is initially 103, minus PTR will make it 101. Let's say we have a pointer to float 106, minus float will become 102. So basically it increases or decreases by the size of its size of its base. Okay, so pointer arithmetic is quite clearly defined differently for different kinds of pointers. So even for this, declaring the type properly is important. So basically what I'm trying to say here is we must declare the type of the pointer correctly, and as we did this, I introduced you to pointer arithmetic and how exactly pointers operate. Now I'm gonna introduce you to a relatively new idea. What I claim is that an array is internally related to a pointer. When we declare an array, like as so, int a open square bracket 5 close square bracket, we are basically declaring an array of 5 elements, each of which are integers. So the program, what it actually does is create a pointer that's called a, and the value of that pointer is the memory location of the first element of the array. So a will point, so we have 5 integers here. This represents 2 bytes because we have 6 dots instead of the regular 3. This represents 2 bytes, this represents 2 bytes, this represents 2 bytes, this represents 2 bytes. So when if we declare a pointer a like so, the program creates a pointer called a. Wait, let me start again. If we declare an array like so with 5 integers, the program creates a pointer called a, and the pointer a points to the first element. And if the pointer a points to the first element, it actually only holds the number of the first byte, because it's an int. It'll know that it has to evaluate both. So basically, its value is the first byte of the first element. A plus 1, because we have declared pointer arithmetic as plus 1 adds by 2 bytes in case of integers. So a plus 1 will this is 1 byte, this is the next byte, so a plus 1 will increase by 2 bytes, so a plus 1 will go here. So if a refers to the first byte of the first integer, a plus 1 will refer to the first byte of the second integer. So basically, if a points to the first integer, a plus 1 will point to the second integer, a plus 2 will point to the third integer, and so on. So that's actually why we've declared pointer arithmetic as a add by the size of the base. So now I guess that makes more sense. So when we actually write after declaring an array int a5, when we actually write cout a2, what the program actually does is this: cout star a plus 2, because a is a pointer which points to the first integer. So a plus 2 will increase by 2, increase by 2, a plus 2 will point here. So we say the star operator says go to that memory address, find out what's there and print it out. So a plus 2 prints whatever value is here. So when we say cout a open square bracket 2 close square bracket semicolon, what the program actually does is cout star a plus 2 semicolon. So basically I just introduced you to the idea that an array is actually a pointer. Okay, now I'm gonna talk about operations related with dynamic allocation of memory. So let's just begin. Dynamic allocation, like I said in a previous video, is allocation that takes place during runtime. It has two operations associated with it, namely new and delete. So this is how the new operator is used. We have a pointer to an integer a, and we say a is equal to new int. So what this basically does is this right side over here, it creates a new integer, and then it passes the address of the new integer to a. So now a basically holds the address of the new integer. So basically a basically points to the new integer. Even though the new integer doesn't have a name, we have a pointer which points to it, and therefore we can always access it by just saying star a. And to assign that new integer value of 5, we can just say star a is equal to 5. Star a is whatever is in a, the thing that is inside the memory location. We make that thing which is inside the memory location 5. Okay, let's dynamically create a float now. You have a pointer to a float b, and then you say b is equal to new float. What this does is it creates 4 new bytes, and then it makes b a pointer to these bytes. It makes b a pointer to these bytes, in the sense that the memory address of the first byte will go into b, but it'll still know it has to evaluate the first 4 bytes whenever you have to do something, because I already explained the reasons before. But basically what this does is create 4 new bytes and then make b a pointer to these 4 new bytes. So although the 4 new bytes don't have a name like regular variables, we can use them. So that's basically how you dynamically um, make new objects. But in case you want to dynamically declare arrays, this is the syntax. I mean the new operator. Yeah, in case you want to dynamically declare arrays, what the new operator does is it returns the pointer of the first element of that array. So let me explain that with code. You say float star b. So basically b is meant to be a pointer to a float. So and then we say on this right side new float a. What this does is free up 10 enough space for 10 contiguous floats, which is basically 4 times 10, 40 bytes. So just keeps on going. It clears off 40 bytes, and then the first 4 bytes will be the first 4 bytes will be the first float. So it makes b a pointer to the first float. Let me explain again. If we say 10, it'll clear up space for 10 floats, which is basically 40 bytes. But the first float is basically the first 4 bytes, as I've shown here, and it makes b a pointer to these 4 bytes. I mean, it makes b a pointer to this first float, so b basically holds the memory address of this first byte, but it still knows it has to evaluate 4 bytes, because I've told you the reasons like twice. Yeah. So when we say star b, we're referring to the first element. So So if we want the first element of these 10 floats, if we, out of these 10 floats, if we want the first float to be equal to 10, we say star b is equal to 10, because star b automatically refers to the first float, because b is a pointer to the first float. And then if we say star b plus 1, since the plus 1 operator on an array of floats will increase the value by 4, basically b plus 1 will is 4 more than just b, so it'll be pointing to the next float. So star b plus 1 will assign a value to the next float, 3.5. Star b plus 2 will assign the value is equal to 8.576, will assign the value 8.576 to the next float, like the next to next float, because it's plus 2 not plus 1. When you dynamically create memory, you also have the responsibility of deleting it, because you tell the compiler, I got this, I'll deal with these variables, I'll create them, I'll delete them. So for deleting this, you use the delete operator. This is how the delete operator works. First, let's say you have an int star a, you have a pointer to a, and then you declare a new integer and make a pointer to a new integer. This is what we've been doing earlier on for so long. And then after you're done with a, you want to delete a. So you basically you don't want to delete a. A is the pointer itself. You want to delete the new integer that you just created. That is, you want to delete whatever a is pointing to. So you say delete a. Internally what it does is it goes to star a, that is, it goes to the place where a is pointing, and then it deletes that value. But if you have an array, basically in the beginning you declare, let's say, an array of floats. Basically what you did in the beginning was you declared a pointer to a float, and then you made cleared 10 new elements, and then new float 10 will basically be the memory address of the first float. So b starts pointing to the first float. So when you delete, you want to not only delete what b points to, but you want to delete what b points to along with the next 9 elements. So you say delete 10b. So b points to the first element of the array. When you say delete 10b, it deletes b, it deletes b plus, it doesn't delete b and b plus 1, it deletes what b points to, it deletes what b plus 1 points to, it deletes what b plus 2 points to, and so on. So I know this was a long video and relatively confusing, but I hope you understood that. If you didn't, I think you should watch the video again, and if you don't, even after that, you can ask me personally. Thank you.